Hi everyone, welcome to this new lecture of hydraulic machines. In this lecture, we'll solve a problem on force exerted by the jet on a stationary vertical plate. So in the last lecture, we have derived an equation based on this force exerted by the jet on a stationary vertical plate. So this lecture will solve a problem on this concept. So here I have taken a question that water is flowing through a pipe at the end of which a nozzle is fitted. The diameter of the nozzle is 100 millimeter and the head of water at the center of the nozzle is 100 meter. Find the force exerted by the jet of water on a fixed vertical plate. The coefficient of velocity is given as 0.95. So the question is given very simple. So in the last lecture, we have identified that the force exerted by the jet of water, that one we have found Fx equal to, we got there rho a v square. So this is the force exerted by the jet on the fixed plate. This one we got in the last lecture. So this is our formula actually to find out. So here what are the data are given? Let's see. So data here is given diameter. First one we can consider diameter of the nozzle, that is d equal to, we can write this is 100 millimeter, and this one we can write in terms of meter 0.1 meter. And next is given the head of water at the nozzle center is given, that is h is given 100 meter is given, and we need to find out the force exerted by the jet of water, and where the coefficient of velocity is given 0.95. So the coefficient of velocity, we can write this is cv, this is equal to 0.95, and the diameter of the nozzle is, this is given here 100 millimeter, and this is this one. So actually the water is flowing through a pipe, and in the pipe a nozzle is fitted to this one. You can see a convergent nozzle is fitted to this one, and from this nozzle the jet of water is coming out with a velocity of v. So this is you can see that diameter of the nozzle is given, and here after striking here the velocity of fluid is coming out from this. So this one we have already discussed in the last class, the derivation part. So based on that we'll solve this one. So actually in this equation, if you see, the force exerted by the jet of water on the plate equal to rho into a into v square. So rho is nothing but density, and a equal to area of the jet, and here we need to consider the area of the nozzle here. So v equal to the velocity, so velocity of the fluid. Now here the velocity, actually we need to consider the actual velocity, but in this question the velocity is not given. Some question the velocity will be given directly, so from that we can easily find out, but here actual velocity is not given. On behalf of that, head given and coefficient of velocity is given. So we can calculate theoretical velocity, from that we can calculate the actual velocity. Anyway, first we will find out the area of this area of the nozzle. Here diameter nozzle is given, so area of the nozzle we can calculate. A equal to, we can write this is pi by 4, and this is d square, and this is pi by 4 into 0.1 square, and we can calculate this one equal to 0.1 square into, this is pi value, and divided by 4, 2.46, and this is, let me check it again, this is 0.1 square into pi divided by 4, 0.0078, 0.0078, and this is meter square area. Okay, and next is, as I told you, first we need to calculate the theoretical velocity of the jet, then we can go for the actual velocity. So we know that the theoretical velocity of the jet of water, v equal to root over of 2gh, and here we can calculate the theoretical velocity. This is 2 into 9.81 into h is here 100 is there, then we can get the theoretical velocity. It's very, very simple here. Okay, so let's write 2 into 9.81 into 100. Okay, and this is we can calculate this root over of this, so 44.294. so this one we can write, this is 44.2 294 meter per second. So this is the theoretical velocity of jet of water. Okay, now we know that the coefficient of velocity equal to, okay, we can write this is actual velocity by theoretical velocity. So actual velocity is not given, we need to calculate, and theoretical velocity already we have identified here. So here we can write the actual velocity equal to CV. CV value is given, this is 0.95, that is 95% of theoretical velocity. So this is 44.294, and we can calculate this value. Just you multiply here 0.95, 42.079. So here we got the value of actual velocity. Actual velocity we got here 42.079, or we can write this is 0.8. This much meter per second. Now we can find out the Fx value. So the force on a fixed vertical plate, as per the equation, we can write this is Fx equal to rho a v square. This is nothing but rho equal to, we know that this is 1000, and this is area equal to, we can already calculated here 0.0078. okay, and area and velocity. Velocity what? This is the velocity. This is 42.08 square. And let finally this must square multiply 0.0078 multiply 1000, 13,000. Oh, this much. Yes, 13,000 here, 1000, 42 square. Okay, something. Then this. So 13,880 11. So this is near about. We'll get here 13,800 something we got here. Suppose 13,811 point something we got this much Newton. So this one we can write in terms of, suppose if you want to convert into kilonewton, then we can write 13.8, and this is kilonewton. So this is the force exerted by the jet on a fixed plate. So this is the answer. I hope you understand this. Very simple question this is actually. This can be asked in the competitive exams with a 2 marks or 2 marks question, or sometimes it will be given the 3 to 4 mark questions also in the semester exams. I hope you understand this problem. Still, if you are having doubt in this, you can give a comment in the comment box. Thank you.